Hello once again. This is a presentation of the results of our studies of age and temporal variation in stellar sea lion population on the Commandery Islands. Stellars are abundant in the west of the North Pacific. And here we see the trends for the variations in their numbers. In the second half of the 20th century, there was a dramatic decrease in the abundance of this type of sea lion, but then it has been increasing in the eastern part, whereas on the Commandery Island and in the Aleutian Island, in the west, it has continued to decline. Understanding the trends and its demographics would be key to understanding the reasons for such a decline. Currently, there is a lack of data over time for the demographics of the species in the region. To evaluate reproductive activity of stellar females and its dependency on age and migration, we used recite data from 1996 to 2016. Recites were taken from the Kozlov Cape and from the Commandery Islands. The tables show sightings in the Commandery Islands and on the Kozlov Cape, respectively, top to bottom. We used robust models to analyze the data so that we can evaluate independently the probability of change of state. These methods are available via marked package for the R environment. So we have Commandery Islands as one of the states, including rookeries and hullouts, and then the other location was the Kozlov Cape. The distance between the two locations is about 200 nautical miles. And now the arrows show potential changes of state. Then we defined two reproductive states, non-active and reproductive, respectively, when a female is not giving birth or given a birth to a pup. And the changes between the two sets of states are evaluated independently. However, there are some hidden correlations between these two sets of states. When females go to the Kozlov Cape, they skip one birth cycle. So when they move away from the Commandery Islands, they, by definition, cannot go into the reproductive state. So to prevent model degeneration, we need to rule out transitions into impossible states. And these are changes of reproductive states that are possible for changes of locational state. Now, recite probabilities. It changes with age, and to the right we can see the variation over the years. These are the probabilities for females not given birth, because the probability for reproductive females is 1. The reason is that they usually spend a lot of time on the rookery, which makes them available for observation. These are survival probabilities of females on weight and age, left to right. And to the left, we have pup survival probability. Weight index varies from 0 to 1, from lighter to heavier pups. And as we can see, pups who are lighter, let's say 25% of the lighter pups, have lower survival chances. And The red curve to the right is the survival probability for females given birth. The other two curves are survival probabilities for females on the Kozlov Cape and Komandorskih Islands without given birth. The filled areas are the 95% confidence interval. The chart shows that the survival probability for birth-given females is lower than otherwise. The models, however, didn't show any correlation with time here. Here we see transition probabilities across different stages that we've defined with dependence on age. Top left is the probability for transition between non-active and reproductive. We see that it goes up really steeply with age. Top right is the chart for the probability of skipping a birth cycle if the female already was reproductive that year, and we see that it's high at young age, and then it gradually goes down. Bottom left is the probability for spatial transitions. That would be going from the Commander Islands to the Kozlov Cape. And the probability is high for young individuals. It goes down significantly by time of active reproduction, and then it recovers. The probability for transition from the Commander Islands to the Cape Kozlov is low at a young age, but then it goes up when females become active reproductively. It goes back down after, which is reflecting the probability of skipping their cycles. And then it goes back up again with age. These are transition probabilities depending on time. Top left is the probability from non-active to reproductive transition, which varies really little. And then the probability of transition from reproductive to non-active is much more varied. Spatial transitions, locational transitions, Cape Kozlov to the Commander Island and vice versa. These probabilities change over time, but not as much as the probability of skipping a birth cycle. The probabilities were used to calculate the shares of birth-giving females at each age for each year. Here are the probabilities for giving 2 consecutive births in 2 consecutive years. The gradient from blue to red shows the increase in that probability. The chart shows that this probability goes up with age and changes over time. Skipping birth is one of the key reasons for variability in the birth rate. This other chart shows the changes of the birth rate over time and with age. We see that the share of females given birth at 4 or 5 years of age has remained constant, meaning that environmental changes do not affect reproductive maturation. These are usually the ages of first time that they give birth. But as we get older, the variation increased significantly. In summary, the results show that environmental changes year on year do not have any significant effect on reproductive maturation, but skipping births was affected year on year, which could be affected by age, conditions, and environmental factors. We saw that 4 to 6 year old females are much more frequent to skip birth cycles, whereas older females do fewer skips. This means that longer interbirth intervals can be a reproductive strategy when females are younger, so that the females can stay reproductively active for longer and more effective with reproduction depending on conditions. Thank you. Now I am available for questions. You mentioned that over the years, there's been no change in survival rates when you spoke about survival for females given and not given birth. So this is a fact that has remained unchanged, meaning that the survival rates are much lower for birth-giving females, right? Yes, the models did not corroborate any change in survival rates over time. But lower survival of birth-giving females as opposed to females that skip birth cycles, this was corroborated by several models. This seems to be a stable state observed in the population. So birth skipping is probably one of the drivers behind the equilibrium in the population. If the females didn't do that, then the variation in survival would be much wider then. Or rather, it would emerge from zero. I'll ask a question then, if I may. My understanding is that females aged 4 to 6 skip birth cycles more frequently. Can the reason be that these females usually have relations with their offspring from the previous year? Well, that's an interesting question, but it's a bit of a chicken and egg here. Do they skip births to stay longer with juvenile, or they just skip birth and then stay with the juvenile because they didn't give birth? If we assume that the relation with the offspring is prolonged, which is significant for the preservation of population, then we would have observed it for older females, probably. So my take on this is that it's highly likely that this longer relationship is a consequence of skipping birth, but further research is required into that. Okay, thank you. I see another raised hand. Yes, by Andrei Tretyakov. Andrei, please, the floor is yours. Hi, Alexei. Is there no direct correlation with birth skipping and decrease in the head count? We have this study. We use the same data for it. It enables us to evaluate birth rates and mortality rates. Then these can be used to build population models and look at the impacts of these parameters on abundance or headcount. On average, observations matched model predictions. So the only variable over time is birth skipping. So when it happens, we see variation in abundance around this overall downward trend. We have a question in the chat to follow up on mine. So what's the share of females that skipped birth and then stayed with their juveniles? Yes, we looked at it. I think you know better than me, actually. Can give you an actual figure because I might remember it wrong. But I think this would be the larger part of females. If they skip birth, then they stay with their juveniles.